number 10. In number 10, we're asked to find, we're given two functions, x squared plus 3x minus 2, and we're given g of x as 3x minus 9, and we're asked to find g comp f of x. Anyone remembers what this notation means and what we need to do?
For the function g, in place of x, you use the function of f.
Right, so this is nothing else but g of f of x. Now, we're going to use this very soon. This is called the inner function. And this is obviously the outer function, which means the inner function is applied to x first, the outer function follows. So therefore, g of x squared plus 3x minus 2 needs to be determined. I know you know this, but allow me to say it once because we need it for the difference quotient and other topics. When I look at for example, at function f, this is what I see. So this is the pattern, and it tells us that you can plug in whatever you want as long as you follow the pattern. If this is x plus h, then this is x plus h, and that is x plus h. The same thing with g. So I see g says 3 times whatever minus 9, but this is my whatever now. So 3 times whatever minus 9. I look at g, and g says, one more time, 3 times whatever you want minus 9. So then we will distribute 3. So 3x squared plus 9x minus 6 minus 9 is minus 15. So that's the function composition of g comp f. So remember, f is the inner, g is the outer in this case. Any questions? Any questions? Stop if you have questions, okay? Everyone? The next one is asking us to, it gives us a function. And it's asking us to decompose it. Decompose this function into inner and outer. And I have to caution you that there is more than one correct answer. I can find an inner and outer, or you can find another. So what do you think would be the inner? Well, the inner function is the function that we evaluate first for this. If I want to replace x by 5, I would have to evaluate this function first. When I'm done and I get a number, I raise it to the 4th power. So the easiest thing to consider, or the easiest thing to do, is to consider the inner function to be what?
5x plus x.
Right, 5x plus x squared. You can denote it the way you like. They say f comma g, so this will be the inner, so this will be g of x. And when you are done and you get a number here, what function do you apply to this number?
X to the 4th.
X to the 4th. So if that's x to the 4th, this will be the outer, so x to the 4th will be f of x. Any questions? Yes?
What is the other one that you see?
Oh, there we have several. So I would consider, for example, one function could be 5x. And the other one could be x plus x squared to the 4th power. So there are many options here. You don't have to consider this as the first function. I can consider this as the first function. And the second one is this plus x squared to the 4th. But the easiest thing to say is, so to come up with, is that this is the inner function, that's the outer. We can have many combinations here. Now, in number 12, we are asked to find and simplify the difference quotient. So let's talk about the difference quotient for a moment, because I needed the entire semester, especially chapters 2 and 3, the difference quotient. So let me just explain what it is. Anyone remembers what it is? Difference quotient. It's okay.
Basically, you plug f of x in where the f of x is not.
No, what is the meaning of the difference quotient? Please.
Is it finding the slope of a specific point in the curve?
You're close. So the difference quotient is basically the rate of change of a function between 2 points. So if this is my function, the rate of change between these 2 points. That's the difference quotient. But I just want to illustrate it quickly for you so you know what it means, so where it's coming from. Because we need to memorize this. And I don't want to just say, hey, memorize this. I'll show you what it means. So it will be easier to remember. So let's say this is point P. This is a function f of x. And please, I'm giving you the x coordinate of P. I would like you to give me the y coordinate of P.
F of P.
You're right, but f of x, correct.
Yeah.
Absolutely. Yes, of course. X comma f of x. There is no question there. Now I'm going to find another point. I'm going to call it Q. And this point has x coordinate x plus a little bit. Yes, I imagine that I zoomed in. And P and Q are not far from each other. So if this is 5, this is 5 plus a little bit. If this is x plus a little bit. So now, can anyone give us the y coordinate of Q?
F of x plus 8.
All right. There is no discussion there. So now I would like you to give me an expression for the slope of the line, the secant line. This is a secant line, not tangent. Secant line, PQ. I would like you to give me the formula for the slope of the secant line, PQ. Yes? Anyone? If we have 2 points, we learned that.
F of x plus h minus f of x.
No. We don't jump like that. Nice try. The slope of a line given 2 points.
Rise over run.
Say it again.
Rise over run.
Exactly. I'm ready. Yes? Aww. F of x plus h minus f of x divided by x plus h minus x. y2 minus y1 over x2 minus x1. So the y coordinate of Q minus the y coordinate of P over the x coordinate of Q minus the x coordinate of P, right? We agree? Right? Okay, so, right, y2 minus y1 over x2 minus x1. Yes, these two go away indeed. So this is f of x plus h minus f of x divided by h, and this is indeed the difference quotient. And yes, it means it gives us the rate of change of this function between P and Q. And the next problem, which is problem 12, it's asking us to simplify the difference quotient. It will not be given to us moving forward. We have to remember it. And we will have to calculate it for different functions. So in this case, we are given f of x, which is 2 the square root of x. And we want to find and simplify the difference quotient for this function. Can anyone get us started? Yes, I will write the definition one more time. And then what do I have from these three pieces, 1, 2, and 3? What do I have and what I don't?
You have f of x.
Excellent. I do have f of x. That's clear. No one can touch h. I can't do anything to it. And the only thing I don't have is this. Now we are complete. So, what is it? How do I determine f of x plus h, and can anyone dictate it? We just talked about it with a different function.
2 radical x, 2 radical x plus h.
Thank you.
Close parentheses.
Very good. Excellent. 2. I swallowed the 2, and I'm not hungry. Okay, very good. That's what it means, f of x plus h. Are we all in agreement? Any questions? Okay, perfect. Yes, I will factor out the 2 and just work on this. And we're asked to simplify it. What do you think we have to do next?
Square the top side and the bottom side.
Okay, be very careful with that. Let's say I'm telling you I have $5 in my pocket. It's not an equation, right? I have $5 and I'm going to square them. Can I square 1/2? Come on, let's square 1/2. Doesn't mean anything, right? You can't do that. If it's an equation, I can square both sides, depending on what I'm trying to do. But square a quantity, I can't. That's not possible. Absolutely. Which part? Yes, please. The conjugate, of course. The square root of x plus h plus the square root of x, the square root of x plus h plus the square root of x. Is that clear, everyone? Yes? Good. We just refreshed our memory on the top. That's one of the special products we reviewed last time. Can anyone tell us what we get at the top?
X plus h plus x.
Careful, it's a difference of squares.
Minus x.
Oh, minus x, yeah.
Right?
Yeah,
It's the
so-
difference of squares.
Right.
First term squared minus the second term squared. Perfect. Okay. So x with x go away. I'm going to write it one more time for everyone to see what is left. And what follows next? Right. And please write 1. And then 2 divided by the square root of x plus h plus the square root of x. I would like us to write this note because moving forward we're going to determine the difference quotient for other functions as well. So here's the note that I would like us to write, but I like to explain it first. Notice what happened at the top. At the top, all terms without h canceled out. Some terms with h may cancel out as well, but definitely the terms without h must go away. What is the second thing that happened? The h in the denominator went away with a factor from the top. The final simplified form of the difference quotient may still have h in it. Yes, of course you will. But that h from the bottom that we started with has to go away in the second step, the second before I write the final answer. And all terms without h must go away. So I would like to write this note down because we are going to refer back to it many times. Note, when simplifying the difference quotient for any function, when simplifying, sometimes I write too fast and so sorry. I shouldn't. When simplifying the difference quotient, dq, for any function, two important outcomes will happen. Number one, all terms without h must cancel from the numerator. All terms without h must cancel from the numerator and the numerator level. Two, h from the denominator of the difference quotient must simplify. Must simplify with something from the top. Any questions? Okay, next, factor the expression completely. Questions for me, please? Anything? Is this okay? So a squared plus 2a everything squared minus 2a squared plus 2a minus 3. This problem is typical for a certain technique that we call substitution. Or in some books you're going to find it as the change of variable strategy or technique. Why do I need to substitute? I don't. But if I don't substitute, then I will have to raise this to the second power and I will have a to the fourth. And then I'll try to simplify combining like terms. But it's still easier if I use a substitution. I'm going to say, let's say t be what? Do you think?
Squared plus 2a.
Right. A squared plus 2a. So then the new expression becomes t squared minus 2t minus 3. Yeah, this is just a tool that makes our life easier. But at the end of the day, I still have to go back to a. So I will go back and substitute t at the very end. Replace it back by with a squared plus 2a. And now this I know how to factor very easily. How do we factor t squared minus 2t minus 3?
T plus 1, t minus 3.
Excellent. All I have to do now is just go back and plug in t, replace it by a squared plus 2a. And a squared plus 2a minus 3. And now each of these factors can be easily factored. How will you factor a squared plus 2a plus 1?
A plus 1, a plus 1.
Excellent. And how do we factor a squared plus 2a minus 3? And we have to write it as a plus 1 squared, though.
A minus 1, a minus 2.
A minus 1, a plus 3.
Or a plus 3.
The order is not important. Any questions? Any questions? Everything okay so far?
Mm-hmm.
Okay. We are given p of x. If you fall behind, if you need more time, please say so, okay? Are you with me? Okay, perfect. So p of x equals negative 3, x plus 4, 3x minus 2, everything squared. It says find the y-intercept. How do we find the y-intercept of this function? And for any function, how do we find the y-intercept?
Plug 0 in for x.
Thank you very much. So for the y-intercept, we find p of 0. So it's negative 3 times 4 times 4. right? So 0 minus 2 is -2, -2 squared is 4, and then 4, and then -3. So -12 times 4 is -48. So the ordered pair is 0, -48. Is that okay?
So you just plug in 0.
The Y-intercept is when x is 0. It's a vertical line at the origin, so this is x equals 0.
Gotcha.
The x-axis is y equals 0, so if I want to determine the x-intercepts or the zeros, I will set y equal to 0.
Gotcha.
Other questions, please? Okay, so here we're asked to find the end behavior. Very important, we're going to use this when we get to graph functions. So in other words, we are asked this. So you may remember this or may not. We're going to talk about the concept of the limit here, and we're going to determine the same thing slightly differently, but the same idea. So we want to know where is this function going. So as x decreases without bound, what happens to the values of the function? When x increases without bound, where do the function values go? So first of all, we have to identify what this is. So what type of function is it? Because every function is different. We look at polynomial functions in a different way, rational functions in a different way, logarithmic functions, exponential functions, trig functions. So they're all different. So what type of function is it? Give it a shot. Polynomial. Degree. It's a polynomial function. Degree.
3.
Yes, indeed. Because 3x, everything squared, will give us 9x squared times x will give us 9x cubed. With a -3 in front, it doesn't matter. Indeed, degree 3, which means it's an odd degree. Okay. You may remember this from pre-calc or may not. All polynomials odd degree behave like a linear function. There are only two options for a linear function. This having what slope? I know I look silly, but I like to do this. Positive slope, correct? And what is the other option?
One positive, negative.
Negative slope, correct? So if the leading coefficient is positive, the linear function does this. Coming from, what's down there?
Third quadrant.
Negative infinity, going to,
Positive.
right. So all odd degree polynomials will behave in the same way if they have a positive leading coefficient. Yeah, they may do something in between, but it doesn't matter. The end behavior will be the same. Does this, since it's an odd degree, does this have a positive leading coefficient or negative?
Negative.
So what is the end behavior then?
Negative.
Coming from
Oh, that's not positive.
positive infinity going to.
Negative.
So please remember that. So it's coming from positive infinity and going to negative infinity. Odd degree with a negative leading coefficient. Odd degree with a negative leading coefficient. Odd degree with a positive leading coefficient. What about an even degree? It behaves like x squared. So if it's positive leading coefficient, it looks like x squared in terms of the end behavior only, of course. If it's an even degree with a negative leading coefficient, it behaves like negative x squared. So odd degree with positive leading coefficient, odd degree with negative leading coefficient. Even degree with positive leading coefficient, even degree with negative leading coefficient. Good. So now the next question, determine the zeros. Again, what is a zero of a function? Zeros of a function. The same thing with I just mentioned it a minute ago.
Intercept.
Very good. So finding the zero of a function is the same thing with finding the x-intercepts of a function. Identical. We just like to confuse people and lose, no, I'm not, no. So we just use two different expressions. So how do I find the zeros of this function? And I'll explain the multiplicities. I'm going to refresh your memory on multiplicities. How do we find the x-intercepts or the zeros?
Solve.
Right, exactly. In other words, set it equal to 0. P of x equals 0. If we don't write an equation, we can solve, right? So negative 3, x plus 4, 3x minus 2 squared equals 0. How many solutions do we have to find? Say it again. Exactly. The degree. Even if they're all the same, we don't care. The degree is 3, we have to find, so degree 3, 3 solutions. I should say zeros, or x-intercepts. So 3 solutions of this equation, or 3 zeros, or 3 x-intercepts, even if they're all the same. So I'm waiting for you to give me 3 solutions.
0, negative 4.
So from here, x equals negative 4. And from here, very good. So 3 solutions indeed. X equals negative 4 and x equals 2/3 twice. And now let's talk about multiplicities. The multiplicity means how many times does a 0 appear? How many times did x equals negative 4 appear as a 0? Exactly. So m equals 1. How many times does x plus x equals 2/3 or 2/3 appear as a 0? So multiplicity 2. 1 plus 2 must equal the degree. Multiplicity 1 plus multiplicity 2 equals the degree. Now here's the next question. What's with these multiplicities? Why do we even talk about multiplicities? Here's why. Last time we graphed x cubed. You remember the graph of x cubed? It's this, right? But the graph of x cubed does not look like this. It does this. Right? So it crosses at 0, but not straight, but very slowly. It takes its time, right? Why? Because there are 3 solutions, x equals 0. Multiplicity 3. Odd multiplicity, like 3, very slowly. Multiplicity 1. Multiplicity 5. Even flatter. What about multiplicity 2 or 4? It always turns. Even multiplicity, it always turns, but it depends on how. So let me just draw a little graph here for you. So this is multiplicity 1. This is multiplicity 3. In other words, this solution here, it doesn't mean that it crosses 3 times. It only means that the same solution appears 3 times. And this is multiplicity 2. And this is multiplicity 4. So even multiplicity always turns on the x-axis. Odd multiplicity always crosses the x-axis. but it depends how, depending on how large the multiplicity is. The higher, the flatter the cross. Okay, so they are asking us now to graph, and here's what I know. I'm going to go back to my little table here. I'm going to put -4 and 0. I'm going to put 0 and -48. This is what we found. And I'm going to write 2/3 and 0. And I'm going to write here turn. And I'm going to write here cross. So multiplicity 1 for -4, so will be a cross. Multiplicity 2 for 2/3 will be a turn. So now I'm going to read my table. I'm going to show -4. I don't have enough. I'm going to change the scale here. So 10, 20, 30, 40, 50. I'm going to say this is -48. It's very hard to plot 2/3, but I'm going to try. So now it's coming from positive infinity. It crosses at -4. Coming from positive infinity crosses at -4 and going to -48. I don't know if it does this. I'm assuming. I think it's unlikely they will turn here because it will be very difficult to come and turn here again. So I think that that's the case. And then comes up to 2/3 and turns and goes to negative infinity according to what we found. Do not worry too much about these graphs because we are going to graph everything, any possible function, with no calculator in chapter 4. But this is what we know from pre-calculus. We did not use calculus here. So I was able to determine the end behavior. I was able to find the x and y-intercepts. I was able to find the multiplicities that will tell us when it crosses and when it turns, and nothing else. Of course, there is an inflection point in there, which we cannot find without calculus and other things. Okay, moving on. Any questions for me, please? Any questions? Okay, in 15 we are given f of x, 12x divided by x squared plus 7. We're asked to find whether the function is odd, even, or none of the above. So non-functions can be symmetric with respect to the x-axis, the origin, and also the y-axis. But functions can be symmetric only with respect to, WRT, with respect to the origin, which makes them odd functions. Oops. Odd functions. Or they can be symmetric with respect to the y-axis. And we call them even. This notation or name does not have anything to do with the degree or nothing. It just says that the function is symmetric with respect to the origin, or a function is symmetric with respect to the y-axis. Nothing else. So then, let's take a look at this. Can you tell me what graph am I representing here? Which graph is this? Which function? Of course, indeed, it is x squared. And I will select a point, x. Can anyone give us the y-coordinate of this point? Of course. Okay, I can't trick you anymore. I got it. So this is exactly on the opposite side. And I would like you to tell me the relationship between f of x and f of negative x. because I can fold this graph with respect to the y-axis. It will be a complete overlap. So then what will you say the relationship between f of x and f of negative x is?
They're even.
They are? Say it again.
They're even.
They're equal. They're the same number. Because the graph is symmetric. Right? So f of x and f of negative x would be the same, right? Let's think of x squared. Is f of negative 4 and f of 4 the same number? Is f of 1 and f of negative 1 the same number for x squared? So this makes it a function that is even. Symmetric with respect to the y-axis. Now let's look at this one. And we've seen this graph last time and today. X cubed. Let's connect 2 points with a line going through the origin. And of course, x and f of x. But on the other side, what will you say? What is this? And what is this? What is this on this side? What is this value?
Negative.
Of course, negative x. And what is this value?
Negative f of x.
Not yet. So I just want f of negative x, because now you're way ahead of me. I love it. Now I would like you to tell me what is the relationship between f of x and f of negative x. You can no longer say they're equal, right? They can be equal. But what is the relationship? So if this is 15, what is this?
Negative.
Right, exactly. So f of negative x is the opposite of f of x. That makes it odd. So these are the two relationships we need to keep in mind. And I always say to my students, please create a notepad in which you summarize all the new information or new concepts or something that you didn't remember or something that you need to review, so that everything is focused in one place. You will find it when you reach, you reach your notepad and you have all the information in there. By day if you want. So please do that. So this is a very important concept. So now looking at this function, f of x, 12x divided by x squared plus 7, in order to identify whether it's symmetric or not, odd or even or not, I have to find f of negative x. This is the key. If f of negative x turns out to be identical with the function, then I'll say it's even. If f of negative x turns out to be negative, the opposite of the function, then I'll say it's odd. If none of these happens, then I'll say the function is not symmetric. So I have to find f of negative x. So f of negative x is 12 times negative x over negative x squared plus 7. Because that's the pattern of the function. When I look at this function, that's what I see. I see f of whatever equals 12 times whatever over whatever squared plus 7. Agreed? So the numerator can be rewritten as negative 12x. The denominator is not going to make any difference. It's the same thing. So now I have 3 questions to ask myself. The first one is this identical f of x? If you say yes, then the function is even. Does this equal the opposite f of x? If yes, then the function is odd, or none of the above. A function cannot be odd and even at the same time. I take that back. There is one function, which is y equals 0. But who cares? This is the only one that is symmetric with respect to the origin and with respect to the y-axis. Who cares about y equals 0? F of x equals 0. Not too many people, right? So if I show that it's odd, there is no point in checking whether it's even, because it's a function. So f of negative x is this expression. Is it identical with a function? Are these two identical? Of course not. One is negative and the other one is not. So it's not even. Is this expression identical with the opposite of f of x? So if I multiply both sides here by -1, negative f of x equals negative 12x over x squared plus 7. So are these two the same?
Yes.
Yes. So I'll say yes. The function is odd. Any questions? Is this okay? Yes, please.
So is the answer when you plug in the negative x, is it negative 12x, or is it this, or does the numerator and denominator
Okay.
both
So
negative?
f of this equals 12 times this. If this is negative x, this is negative x, and this is negative x. Is that okay so far?
Mhm.
Okay, so 12 times negative x is negative 12x over, and this is clear, x squared, right?
Mhm.
A negative divided by a positive is a negative 12x over x squared plus 7. Now, I can, if I consider both top and bottom negative, then I change the whole sign. So if the top is negative, the bottom is positive, then the whole thing is negative. Better?
Mhm.
Perfect. Any questions here? Okay. Next problem. Did I turn the page without? No, that was it. Okay. So here we have an equation. I see. Can anyone tell us what equation is this? Say it again. Very good. Awesome. It is a log equation. How do we solve a log equation? First of all, we have to state restrictions. For this log, what is the restriction we have to write? What type of numbers we can apply log to?
Positive.
Very good. X minus 2 must be positive. What about this? The condition for this to exist. What do we apply log to? This is not different. So what would I write? X plus 3?
Greatest.
Of course, yes. I just want you to say it. So when I graph these two, remember I have to intersect. We've done that with f of 1 and f of 2 from last time. The first one is 2 and above. I don't care for units. I'm using the real line just to express what I need. And -3 to infinity. Like with the function from last time, the square root plus another square root, where we had to determine the domain for each, we have to intersect. But the left-hand side has to exist, and both logs have to exist at the same time. So I need both colors, purple and orange. So what is the condition for the solution? Without which, if it's not in that interval, the solution cannot be accepted. Which interval are we talking about? Of course, thank you. So indeed, if 2 is not great, if x is not greater than 2, the solution, whatever we find, cannot be accepted. Now the question is, how do I condense? I have to condense the left-hand side. How do we condense it? How do we condense log expressions? Say it again.
Multiplication.
Yes. Log base 6 of x minus 2 times x plus 3 equals 1. Very good. Log applied to a product is the sum of logs. Excellent. It's not log times log, but log applied to the product. Great job. Okay, so now this is equivalent to an exponential equation. Do we remember how to change this into an exponential equation? X, 6 to the first power, very good, equals x minus 2 times x plus 3. Awesome, well done. So then, this is quadratic now, I will FOIL. So x squared minus 2x plus 3x minus 6 equals 0. So the equation that we need to solve now is quadratic. I just multiplied, moved terms around, and I set it equal to 0. So let's factor. What do we get? So there are two options, x equals and x equals. The first one is, and the other one. And you should say not so fast. You just spend a lot of time explaining how to find the domain. So what will you conclude? -4 cannot be accepted. Very good. Great job. Any questions? Yes, please.
Why didn't, when you're finding the domain?
Yes?
Why didn't you, can it equal to 0?
No.
It can't equal
No.
to 0.
No. Very good question. And this is a perfect moment to refresh your memory on the graphs of log. Thank you. Because we need it. We need it for limits. So it's a perfect time. So this is log base a of x when the base is greater than 1. And this is log base a of x for base between 0 and 1. As you see, this is a vertical asymptote. X cannot be 0. The domain of the log function is 0 to infinity. Very good question. Thank you. So please remember the graphs of the log. Okay, number 17. Can we move on to 17? Questions? And number 17, I would like to refresh our memory on pi over 6, pi over 4, pi over 3, sine, and cosine. That's all we really need. Very easy to remember, I think. Sine pi over 6 is the smallest angle, and sine is 1/2. So is the opposite, in other words, cosine for 1/3, pi over 3. Now, cosine pi over 6 is that ugly one, the square root of 3, and so is sine of pi over 3. So see, these two go together, and these two go together. And pi over 4 is the easiest to remember, because they're both the same, the square root of 2 over 2 and the square root of 2 over 2. That's really all we need to remember. Don't bother with tangent, secant, cosecant. As long as you know the relationships between the trig functions, you don't need any of that. So in our problem, we are asked to find tangent pi over 4. Who cares about tangent? It's so easy to remember this one, but I would say, just to be funny, who cares about it? I know it's sine pi over 4 over cosine pi over 4, and since they are both the same, this must be 1. Now the next one is sine 7 pi over 6. Well, this is a different story. Why is this a different story? It's only because here I have to think a little bit. I have to find the quadrant where the terminal side is. I have to find whether sine is positive or negative there. And then I have to find the reference angle. And then I have to think. a little bit more, right? So I have no idea what 7 pi over 6 means, but I know that this is 30 degrees. So 30 times 7 is 210. So now I know that this is 7 pi over 6. And it ends in the third quadrant, 30 degrees over 180. And this is the reference angle. RA, reference angle. Which is pi over 6. But sine, if you remember, sine is measured above the x-axis, positive, right, on the y-axis. So above is positive and below is negative. Cosine is measured on the x-axis. It's positive on this side, 1 and 4, and negative on this side, 3 and 2, 2 and 3. So positive for sine, negative for sine. So therefore, this must be negative sine of the reference angle. But we know sine of the smallest angle is 1/2. I just need to put negative in front of it. Any questions? Any questions? Are we okay with this? Yes? Could you follow? Yes? Okay. Secant, 5 pi over 3. Who cares about secant? Nobody talks about the secant. It talks about 1 over cosine 5 pi over 3. And that's more like it. Why am I saying this? Because I'll never ask my students to memorize anything about secant, other than it's 1 over cosine. So I have no idea what this is, but I know that this is 60, and 60 times 5 is 300. So it's 60 degrees shy of 360. So this is 60 degrees. I divided this into 3 parts. So this must be 5 pi over 3. The reference angle then must be pi over 3. So that's the reference angle. So cosine is positive here and here, 1 and 4. So therefore the answer is 1 over cosine pi over 3. And now we know that cosine pi over 3 is 1/2, right? And then we write 1 over 1/2, which is 2. Remember one more thing, I mentioned that last time, and I want to mention it again. If I show you a method and you know you're comfortable with another one, I do not ask you to switch. If this method makes more sense, switch to it. If it doesn't make more sense, stick with what you know. Okay, please. Okay, so here we have to find the x values to solve this trig equation. Sine twice x equals sine x. And they want us to use 0 to 2 pi. Not present all infinite possible solutions, but just present 0 to 2 pi solutions. And I think we have just one more after that. No, 2. Okay. Well, if we don't remember the identity of the double angle, then we'll have a hard time with this trig equation. Do we remember what sine twice x equals to?
2 sine x cosine.
Awesome, thank you. So this is 2 sine x cosine x. I'll move sine x and set everything equal to 0. Excellent. So now, what next? Awesome. Thank you. 2 key words I would like you to remember forever. Factor and simplify. Key words in everything in math. Factor and simplify. Please keep those in mind at all times. Excellent. So we factor our sine x. We have 2 cosine x minus 1 equals 0. So therefore, we have two solutions. Either sine x is 0 or cosine x is
One.
over 2. Perfect. Okay, back to the unit circle. Where is sine 0? Remember, sine is measured on the y-axis. So where is sine 0? Exactly. So sine is 0, x equals 0, x equals pi, x equals 2 pi. Well, 0 and 2 pi is the same place, but never mind. Okay, where is cosine 1/2? So it has to be in the first quadrant and the fourth quadrant. But just a minute ago, we determined this, one of them, 5, 5 over 3. So there are two options here, x equals pi over 3, and the other one is 5, 5 over 3. We just determined it. So basically, this is pi over 3, and this will be 5 pi over 3. This is pi over 3, and this on the same vertical, because this little piece is cosine. The piece between these two, which is 1/2. And questions? Y equals 3 plus sine twice x. You couldn't have anticipated better, right? Last time you asked about the horizontal stretching and shrinking. So what is the period of plain, simple, base function sine x? What is its period?
2 pi.
Correct. But what do you think will be the period of this function? Don't say anything. Just remember, we changed x into twice x. What does that do? It's the opposite of what you would think.
The period of shrink.
Exactly. So the period will be 2 pi over 2, which is pi. Exactly. So if we graph pi to pi, 1 and -1, if I graph sorry, I got carried away. So this graph, the pink graph, is sine x. So this is sine x. Now if I graph sine 2x, I will have to graph this. And yes, I can continue. This will be sine twice x. But now I also have the 3 in front, or just added. So it will go up to 3 and down to 3. This is just one complete rotation. 3 plus sine twice x. And let's really quickly